half hourly data. So I'm going to pause this presentation and open up the raw data file. So I'll come out of PowerPoint momentarily. So this is an example of the raw data that you would get from your half hourly meter data. Let me just expand out some of these top rows. So if I zoom in, what you have down the side is your MPAN number. Typically this, if you may have a different meter name, but in this case, you know, this is our MPAN number, starting with a 14 for our area. This is the date of the reading. So I have here from the 1st of the 1st 21 all the way to into 22. So I have a good full year, over a year's worth of data. And then along the top here we start with our 00, midnight, 12:30, 1:30, all the way across to, if I open this up a bit, to 11:30 p.m. So 48 data sets, one for each half hour. We have a flag in the middle, which is just to confirm that the reading has been taken correctly, A for automatic. And finally, we have a description. So this is consumption in kilowatt hours. So between midnight and 1:30 a.m., it consumed 10.2. Make sure I zoom in. It might be difficult to see on some screens. 10.2 kilowatt hours, and between 12:30 in the morning and 1 o'clock in the morning, 9.6. So the total is 9.6 plus 10.2. So the total for the first hour from midnight to 1 a.m. is 10.2 plus 9.6, well, 19.8 kilowatts. Now, so the first thing to do with this data is we need to start cleaning it up. So rather than doing an Excel exercise, what we want to do is basically keep the description, because below we have consumption here in kilowatt hours, but also in the raw data, as I scroll down, we have reactive energy lagging. Keep scrolling down for the period. See, we're already on row 685 here. And we have reactive energy leading. So this is our real and reactive power, lag, lead, all together in the half hourly data. So if I just come back up to the top of the screen. So the first pass is to clean up this data, and what we want to do is effectively get rid of the MPAN. We know there's that column, and we want to get rid of this flag column. Now, depending on your skills with Excel, you may be able to do that very quickly, but what I've done here is kept the time, so clean one as I describe it. Zoom in. So I've kept the description of whether it's kilowatt hours. So you can see I can select kilowatt hours, reactive energy lag, reactive energy lead. The dates I've all in, and effectively I can select 2021. I have the full data for 2021, which is what I'll use going forward. And for 22, I just have January actually, so I'll just be using the 2021 data. Normally it's easy to analyze, or preferable to analyze, a full calendar year worth of data, and it's just a little easier to think of it from January to December. And as I say, I've got rid of the flag, so I have 48 columns of the time here, showing all the way from midnight to midnight. And this is the actual kilowatt hours, so the real kilowatt hours. I can select the lagging. So this lagging, again, due to motors and compressors. In our example here, I should say it's a golf club. So these relatively small figures, but reflect air conditioning, fridge compressors, freezer compressors. So there is that. And for leading, which again was capacitive, 0. So there's no capacitive loads on the golf club. It's all lagging, which is what you'd expect in 90%, 99%, perhaps even higher. Most people would have a lagging element due to motors. Very few people would have leading element for capacitors or a capacitive load. So just select all. So that's step 1. And then what we want to do is just get the consumption on its own. So I've taken the consumption. So I just select consumption. I want to select just 21. And simply it's a case of copy all of that, Excel copy, and then paste it. So I have date 21 only, and I know this is the consumption, so I've taken out the consumption column. So I have the date from January the 1st all the way down to 31st of the 12th, 21, and I have the half hourly consumption for each period. So if I zoom out, you can see oops, that's very too much, but I suppose it gives you that's the sense of the block. So 365 days with the hours along the top, the actual half hourly data. Oops. So from midnight, all the data. And similarly I've done with lagging and leading, but there is no leading kilowatt hours, it's just lagging. So lagging, total kVA 21,000, total kilowatt hours here 181,408 kilowatt hours is the total electricity consumption for this golf course in the year 2021. So what I'll do now is return to the body of the presentation. So a bit of jiggery pokery.